compiler. In our last video, we have discussed regarding the phases of compiler. In that, we have seen that the compiler phases, they are generally divided into two parts. One is called the semantic analysis, and another one is called synthesis analysis. So analysis phase, it is divided into like lexical analyzer, syntax analyzer, semantic analyzer, and intermediate code generator. And synthesis phase, it is having two part like a code optimizer and code generator. So based on that, we have also discussed regarding all the functionality of each and every phase. Now with the help of diagram, now we are going to understand how the high level language code it is converted into machine code by passing through the different phases of the compiler. So here, suppose there is one expression or high level language statement. For example, we have taken one example here, sum equal to sum plus rate into 50. So this is the input to the lexical analyzer. So lexical analyzer first try to identify each and every single element of this particular statement. So after reading one by one character, lexical analyzer understand the meaning of this particular sentence is that identifier is equal to identifier 2 plus identifier 3 into identifier 4. So from this it understand that the identifiers and what are the different operations they are going to be performed on this identifier. So after grouping them in the meaningful sentence, the lexical analyzer produce one type of output that will be the input to the syntax analyzer, which will be understanding the meaning and produce the parse tree. So it understands that the meaning of identifier and the operation which is going to be performed on these identifiers. So it produced the parse tree. In that it is mentioned that the multiplication of these two identifiers, and after finding the product of these two, it has to be added with the identifier 2, and this total expression value it will be assigned to the value of identifier 1. So identifier 1 will be equal to the multiplication of identifier 3 and identifier 4, and that product will be added with the identifier 2, and that total value of this product and addition that will be assigned to the identifier 1. So in this way the parse tree will be generated from the syntax analyzer, and then that syntax analyzer, whatever the parse tree is generated by syntax analyzer, that will be the input to the semantic analyzer. It further perform type checking and all that things, so that the perfect result of the particular operation can be found. So it perform type checking, so in that way it will add some literals like whatever the integer value, what are the real values are there. So after producing all this entire parse tree with all type checking and all checking are done, so that will be inputted to the code generator, intermediate code generator. The intermediate code generator then produce the intermediate code by using the temporary variables like this. So temporary variable 1 is equal to the value of that particular constant. Then temporary variable 2 is the product of id 3 and temp 1, that is whatever the value of the constant is there, that is added with this one. And then the total expression, it has been given the value as temp variable 3 or temporary variable 3, product of id2 and temporary variable 2. And then the final expression will become id1 equal to temporary variable 3. So in this way the intermediate code is generated, and it has been assigned to the code optimizer, so that it can further perform code transformation to optimize the intermediate code, so that it can generate the intermediate code efficient and fast execution. Fast executing intermediate code is inputted and it is produced by the code optimizer, and then code generator will produce the assembly code of that particular expression and meaning of that code. In that it is using the mnemonics of the assembly code like by using the registers it performs the operations of whatever the expression operations are there. So like this, by using all these temporary variable, the code generation phase will perform all the necessary operation that are performed on this code generator. Now after this, the next input phenomena of that particular that is called as the difference between the pass and phase. So in this way, the code optimizer will work for producing the temporary whatever the input expression is there, it is going to produce the output on that particular code. Now coming to the next terminology that is called as the difference between pass and phase of the compiler. So here we are going to discuss regarding what is the difference between the pass and phase of the compiler. The pass and phase of the compiler, as we have seen that in the phase diagram of the compiler, the phase of the compiler or phases of compiler is nothing but the individual unit which are going to perform certain operation on the target on the source program and produce some form of output that is needed for the next phase of the compiler. So phase is nothing but that is the individual unit of the compiler program which performs certain operation in the translation process of the source program into the target program. Now coming to the difference between pass and phase, so first we'll see what is the meaning of pass of the compiler, and then we are going to discuss what is the meaning of the difference, what is the difference between these two things. So first we are going to define what is the meaning of pass of compiler. So pass is complete traversal of source program. So compiler has two passes to traverse the source program. Means complete reading of the source program is called as pass of the compiler. And phase is the individual unit of the compiler module, like lexical analyzer is phase, semantics, syntax, and intermediate code generator. So all these are the phases of the compiler. But pass is nothing but traversal or complete scan of the source code that is used for producing the object code. So that is called as pass. So generally we have seen that the compiler program or phases of the compiler, they are grouped into the two phases or two sub phases or main phases, that is called as the analysis phase and synthesis phase. So in the analysis phase we are having these four phases of the compiler, and in the synthesis phase we are having these two phases. So in this way we can say that this is the example of two pass compiler. So pass of the compiler is nothing but the scan of the compiler to produce this one. If a compiler program take two scan for producing the target code, so that particular compiler, it is called as the two pass compiler. So pass is a complete traversal of source program. Compiler has two passes to traverse the source program. Then multipass compiler. So multipass compiler is used to process source code of a program several times. So in a particular case, if the source code is read for many times, or if it requires scan for many times, so that particular compiler, it is called as multipass compiler. In the first pass, compiler can read the source program, scan it, and extract the tokens and store the result in an output file. So first pass, that is regarding the reading of the tokens and producing the token, extracting the tokens from the source program. So that is one pass. Then in the second pass, compiler can read the output file produced by the first pass, build the syntactic tree, and perform syntactical analysis. The output of this phase is file that contains the syntax tree. So in the second pass, what is going to happen is that the whatever the tokens are produced by the lexical analyzer, that is the input to the syntax analyzer. So that syntax tree, so it will be performed syntactic analysis, and output will be a syntax tree. In the third phase, compiler can read output file produced by the second pass and check the tree follow the rules of language or not. The output of semantic analyzer phase is annotated tree syntax. Means the complete type checking and all that things are done in the third pass. In the third pass, and the annotated tree is produced. Now that is the next is this pass is going on until the target output is produced. So this is regarding multi-pass compiler. Now one pass compiler, see the difference is that one pass compiler is used to traverse program only once, or it is going to be read or scan the program only once. The one pass compiler passes only once through the parts of each compilation unit. It translates each part into its final machine code. In one pass compiler, when the line source is processed, it is scanned and the token is extracted. Then the syntax of each line is analyzed and a tree structure is built. After the semantic part, the code is generated. The same process is repeated for each line of the code until the entire program is compiled. So in this way, the one pass compiler is nothing but the compiler in which there is only one scan of the source code for producing the target code. So that type of particular compiler, it is called as one pass compiler. And multi-pass compiler, when there are multiple scans of the source code is required for producing the output code or the object code. So that case of the compiler, it is called as multi-pass compiler. So in one pass and multi-pass, the target of the code is the machine code. So if it is produced in one pass or one scan of the particular compiler program, then it is one pass compiler. And if the target code is produced by multiple scans of the source program, then that particular compiler, it is called as multi-pass compiler. Now, so this is regarding the difference between the one pass and multi-pass compiler. Now there is the second thing that is called as bootstrapping. So these are the terminologies which are generally used in the compiler construction process. So we have seen that the pass of the compiler, and now we are going to move towards bootstrapping. So bootstrapping is basically wide compilation is a technique which is widely used in the development of the compiler program. Bootstrapping is used for self-hosting compiler. Self-hosting compiler is a type of compiler that can compile its own source code. Bootstrapping compiler is used to compile the compiler, and then it can be used in the compiled compiler to compile everything else as well as future version action. Bootstrapping is nothing but is the process which is used in the compilation development. So bootstrapping is used to produce self-hosting compiler. Is a compiler that can compile its own source code. Means for building the compiler program itself, it requires, means compiler program has to be compiled once again. Means whatever compiler program we have developed, that has to be compiled so that to check whether it is going to produce the correct output or not. So that particular process is called as bootstrapping. That's why bootstrapping is a self-hosting compiler, is a type of compiler that can compile its own source code. Means generally we are using compiler to compile another programs, find out the errors, find out the output. But whenever we are going to develop compiler program, so that program after development has to produce output, and is to be checked whether it is going to produce the correct output or not. So that for that particular purpose also we require a program for compilation process. So that compilation program, it is called as bootstrapping program. Bootstrap compiler is used to compile the compiler, and then you can use this compiled compiler to compile everything else as well as future version of itself. Means it is generally used for construction of the compiler. It can compile its own compiler program, or it can compile another programs also. So in this way, the compilation process is to be used for a compilation or compiler for a program. So as this bootstrapping is generally a particular phenomena which is going to be used during the development process of the compiler, and it is generally used in the process where we are going to develop the compiler program itself. So Self-hosting compiler program is called as Bootstrap program of the compiler. So in this way the compiler program works. So that particular compiler program, it is called as bootstrapping or self-hosting compiler, which is going to be used for the purpose of construction of compiler program, which can compile another compiler program or its own future version also.